In primary school, I wasn't a very high achieving student. Hi, I'm Dr. Scott Banks. I'm a lecturer in Chemical and Sustainable Engineering at Aston University. My research is focused on thermal conversion of waste streams and biomass streams into useful products such as alternative fuels or higher value chemicals. So I've brought with me some examples of some of the feedstocks that we look into converting. So we've got wood pellets and plastic wastes. It's looking at converting these feedstocks into two different types of resources. So we have a solid, which is biochar. This can be used for soil treatment. It can also be used for water and air filtration. And then we can also have a liquid product. We can upgrade this either to a sustainable aviation fuel, or it can be used for upgrading to fuel for your cars or to different chemicals. So it's all looking at sustainable alternatives to current petrochemical fuels, chemicals, approaches. So sustainable options for the two. When I was in primary school, I wasn't a very high achieving student. So I struggled with my maths, my English, most of the subjects. But I had teachers in secondary school, when I got to secondary school, that really jolted my interest in the sciences and in maths. And that's where I led on to doing them all three sciences at A level and the maths and further maths. I started off with no real interest in school, and then finished it up going to university, finishing a PhD and being a postdoc, and now a lecturer and teaching. So I think it's becoming having the people around you that can help you spark that light and where you want to go. So you don't need to know what you want to do straight away. Most excited on a teaching side, I love that my course has international students. So we've been having positive and negative discussions when we're looking at sustainability and different approaches like that. One of the things that we were discussing with some of my students from Nigeria, they'd have different ideas on what should be done and what should be prioritised, but they were having a very in-depth discussion with people from China, so who have a completely different viewpoint on what should be looked at, what sustainable approach is. But it ended up with them both agreeing, or both sets of countries agreeing, that there's positives and negatives to both of their approaches. So it opened the students' eyes that there's nothing set in stone. So I always look forward to student interaction with those type of conversations. So I've received a really nice question from a school pupil, and it's regarding my research and how long it's taken to get to this scale and into development. So taking it back to the basics of the actual technology, it's been around for many decades. So my professor, when I was doing my PhD, he's now been working on it for 50 years, the actual technology. The part that I work on is then using it for different applications. So start tweaking the parameters such as temperature and reactor design to what feedstock we're going to use and what the potential products are going to be. So I've been working on this field for the last 12, 14 years. So it takes a long time to get to where you want to get to, but with using research from the past and people's experiences, you can get to where you want to go to. So IDRIX allowed me to take my fundamental research and practical research, so from lab scale, and start utilising that and showing the impact that it can have on industrial partners. So it's given me that platform to start those collaborations, those discussions with industry. So It helps me develop my research, it helps me have a greater impact in industry, and it helps industry show they're starting to develop these decarbonisation pathways that everyone's trying to identify.